Hi, everyone. We're going to work to understand how your money grows when you save or invest your money. So, we're going to talk about simple interest, which is one way in which money can accumulate its interest. And then at a different point in time, we'll talk about compound interest. But here, the focus is just on simple interest. We'll really just be doing calculations involving simple interest. But first, we want to build up the concept of what simple interest is and how it works in terms of affecting the growth of money in an account. So we're just going to look at this sample situation right here where Marina is depositing $1,000 into a CD for a period or a term of 5 years' time. The bank will pay 3.75% simple interest on the account. So it's a very high interest rate. It's not realistic, but it's just kind of a nice number that we'll use for this. All right, so we're just going to organize the amounts of money she has in her account each year in the table below. So I'm just going to use years 0, 1, 2, 3, 4, 5 to know what her ending balance in the CD is at the end of each of these years. So clearly at the end of year 0, the amount that's going to be in her account is going to be $1,000. So $1,000 right there. So whenever we are given an interest rate for an account, it's always an annual interest rate unless it's stated otherwise. So what that means is that annually or per year, the account will grow by that percentage of the amount that's in the account. So it's a 3.75% simple interest rate. So what should happen then is going from the end of year 0 to the end of year 1, we should see a 3.75% increase of the amount in the account. So what we should see is we should see a 3.75% increase of $1,000. So what I've written there is I've written the decimal version of 3.75%, which is 0.0375. So that's just the result of taking the decimal point of 3.75%, right? And moving that over a couple spots right there. That's where we get 0.0375. And then we're going to multiply that with $1,000. So what that does equal is it equals $37.50. So that amount of increase from the end of year 0 to the end of year 1 results in a balance of $1,037.50 for that ending balance. So the way that simple interest functions is that then when you increase from the next year, it's always going to be 3.75% of your starting balance. So it's always of the 1,000. It's not of the most recent balance. So what that means then is the amount of increase each year always actually stays the same. So in this scenario, it'll always be $37.50 of an increase each year. So you'd end up with a balance then of 1,075 in that year too. So that pattern really is just going to kind of go on and develop as such. So what you're going to kind of see then in terms of interest accumulating over time is that if we wanted to know, let's say in 5 years' time, how much interest we are going to have accumulated, then what you would want to do is you would want to take your 3.75% of your $1,000, so times $1,000 with the 3.75%, that's going to give you the increase for 1 year's time. So if you multiplied that with the number of years, which would be 5, that would give you the total amount of interest that you would accumulate. So if you put that in a calculator and you times all of those things together, you end up getting an amount that is $187.50. So that's really $37.50 5 times. So that would actually tell us then that this $1,187.50, which is $187.50 higher than 1,000, is going to be the ending balance at the end of year 5. So if we kind of just filled in the rest of this table just so that you have it, you'd have 1,112.50 if you increase by 37.50, and this would be 11.50 there for year 4. So basically, what you have to understand about simple interest is that simple interest is going to be interest growth that is a percentage of the principal. And by principal, we mean the initial amount that is in the account. and I'll define that in just a little bit. So simple interest just has that characteristic in which you're always increasing based off the original amount, which means that you're just going to keep adding the same dollar amount from year to year if you have a simple interest account. So there is a nice kind of formula that we can use for simple interest. And so formulaically, if you kind of take a look at what I did right here, when I tried to figure out the amount of interest we would have after 5 years, okay, what I did is I took this amount right here, $1,000, that I'm going to label with P. And P stands for the principal, or the original amount that's in the account. And then I'm going to label this amount right here with R for the rate of interest, but expressed as a decimal. And I'm going to label this right here as T, as in time. So when we multiply the principal with the rate with the time, we end up getting the amount of interest that you have accumulated. And so that formulaically is something that we can always use whenever we're dealing with something involving simple interest. So an identity that's really important for you to know is this formula right here for simple interest. It's a very purdy formula, if you get what I mean there. But yeah, just to delineate each of the variables right here, the P stands for the principal, which is just the starting deposit, so how much you put in the account at the very beginning. And then we have the variable R, which stands for your annual interest rate. So it's really important that you recognize that it is the annual rate. So it is the rate of growth for 1 year's time, not over a week, not over a month, not over 10 years, for 1 year's time. And we would want to always express that as a decimal when we're dealing with the mathematics of finance and interest rates and such. Yeah, and then T stands for the time, and that always is in years. So if you wanted to figure out a problem where the money was going to be in there for a certain number of months, then you'd have to convert it to years. So time in financial math and that sort of thing is always in the unit of years, and that's really important as well. And then finally, I is just the amount, the dollar amount of interest growth that has occurred. Okay, so what's really important to understand is that this formula doesn't actually tell you the amount that is in the account directly. What I mean by that is when we use this I equals PRT formula right here, and it gave us this answer of 187.50, it gave you only the amount of growth. It did not give you the amount that was in the account right there of $1,187.50. What we needed to do is we needed to take this interest and add it to the $1,000 principal to get how much was in the account. And that's what I want to establish next. So I'm going to introduce one more variable, A, which is actually going to stand for the amount that is in your account, or that we might specify as being your account balance. So one formula that we can use is that account balance is actually going to be your principal, which is how much you start with in the account, right? And then add to that the amount of interest that is accumulated over time. So that identity right there is also helpful for us to understand. But now I need you to recognize that if we're dealing with simple interest, that I is actually equal to PRT. So just by doing a replacement, we also know that amount in the account is principal plus PRT just by doing that replacement of I. So you should recognize that that identity right below also is going to hold, and it's just the same thing as above it. But then just by doing a little bit of algebra, because this term right here has a P and this term has a P, that's like a common factor of both of those terms. So if I factor out the P from both of those terms, we would get P times 1 plus RT, right? So think about that, right? Just by the distributive property, if that P distributes, then you'd get P plus PRT, which is the same thing. So this identity, which is still identical basically to the ones above it, also is going to hold for simple interest. So those will be some things that you can also utilize in terms of understanding and working with simple interest. One last thing that I want to help you understand and conceptualize about simple interest is just kind of a characteristic of the growth of simple interest over time. So I'm just going to sketch out just a little graph right here. And so I'm going to make this graph have an axis of time and then an axis of the amount that's in the account. So we're going to look over time, how much money do you have in your account, right? So what'll happen anytime you have simple interest is the growth is going to always look like this. It's going to be a straight line. Because what happens with straight lines is they have a constant rate of change, or in other words, the slope is always the same. In context, that really means that the money that you increase by each year is always the same dollar amount, and that definitely is happening right here. So this point right here should actually be the starting amount in your account. So in our case, with Marina, she started with $1,000. And then what should be happening over time is that once we get to 1 year, we should see then that the amount that's going to be in her account is going to be an increase of $37.50, which just really means that you're going to go up 37.5 for a rise and a run of 1. So the slope is going to be 37.5 over 1. So we can actually write an equation for this. If you think back to algebra and writing linear equations and stuff, you can think that the equation for this is really just y equals 1,000 plus 37.5t. So think about what I just wrote right there. So the 1,000 is just a number, which means it's going to be your y-intercept, which is what we have, right? And then your 37.5 is timesing with the t variable. You can think of it as being x, which then has to be the slope. And that really is what's happening because it's going up 37.5 over 1 each time, right? So it does fit into that notion and idea of what we know about linear equations and such, right? And that actually really does fit in nicely because you'll notice that when I wrote the equation that you see right here, that the amount is equal to principal plus principal rate times time, you should be able to see a connection in that the $1,000 that you see right there is actually the principal, right? So that lines up and matches up nicely there. And then you're also going to be able to hopefully see here that the 37.5 that's timesing in front of the t should be the same thing as what's in front of the t right there, which should be the result of doing p times r. And if you recall, that exactly p is $1,000 and the interest rate is 0.375. When you times those two things together, you get 37.5, which indeed is what that number is timesing in front of t, which is the slope. Okay, so it's really, really important that you recognize that whenever you put money into an account that grows with simple interest, it's just going to grow linearly. So like a line, it's just going to add the same dollar amount per year accordingly. Okay, so just to summarize, you should understand that in terms of, in a table and seeing that linear growth over time. And then these formulas that we've written in the purple there are important identities to understand about simple interest. And then you just kind of see and conceptualize that in terms of the graph there. So for the remainder of this, we're just going to kind of look at some different problems to help you gain and ground familiarity with simple interest and some of the computations that you should be able to perform should you have, your own investments and savings invested in accounts that are earning simple interest. So we're going to start with this first scenario right here. So we're going to try to use the same scenario with Marina to determine how much money Marina earns in 9 months' time. So how much she actually earns, which would be the amount of interest. So if we know that she's earning simple interest, we can ground ourselves in the identity of interest equals principal times rate times time, right? So to compute that amount of interest here, we can take her principal, which we know is $1,000, and we can take her rate, which is 0.375, expressed as a decimal, and then the time. So here's the thing, is that this is 9 months. So you cannot put 9 right there because time is always in years. So you'd have to convert that to be in terms of years. So since there are 12 months in a year, then 9 months is equivalent to 9/12 of a year. So you'd have to substitute in 9/12. If you know that that's 3/4 or 0.75, of course you can put that in there as well and then compute the amount of interest that you would have using that formula. So once I get this typed in here, This ends up evaluating to 28.125. Um, so maybe it would round up to 13 cents, but just for the sake of maybe it doesn't make it there, we'll just round it down and say that we only grow by 28.12 cents. So that would tell us then that the amount of interest that we would accrue there would be $28.12. There is a second question here that's asking how much total money is in her account after 9 months. So that would be her account balance, of course. So since she started with $1,000, if we add $28.12 to that, then her account balance would, of course, be $1,028.12. All right, and then I just want to make sure that this is the same thing, but this is just how much is earned after 90 days, and then what would be the total amount that's in the account after 90 days. So pretty much just a similar sort of thing. So the interest would be equal to the principal of $1,000 times the interest rate, which is again 3.75%. But then if it's 90 days, you just have to think of the fact that there's 365 days in a year. So you would use that as your denominator to convert it to years. And so it'd be 90 365ths. That would compute the amount of interest that you would accumulate there. So if I evaluate that here, my calculator, we end up getting approximately 9.246 and a whole bunch more decimals. So we'll just say like $9.24 just to round it down. So interest would be $9.24. And then that second question there is just asking what's the total in the account after the 90 days. And so that would just be an increase of $9.24 to the 1,000. So you'd end up having $1,009.24 there. Great. Okay, so the backside here, we want to gain some familiarity with problems where we're not necessarily just working out the amount of interest. So in this particular problem here, we're looking for how much principal must be deposited to earn $2,000 in simple interest in 5 years' time at a rate of 2.5%, right? So you can see that like we are earning simple interest. So simple interest should be able to clue you into the fact that I equals PRT is an identity that we could possibly use, right? And what I underlined in the purple there is we were asked for how much principal needs to be deposited. So we don't really know how much principal you can plug in, right? But what we want to do is we want to earn $2,000, which means that we want to increase by $2,000. So that does correspond to an amount of interest that is known for us. And we also know that right here, we want it to happen in 5 years' time, which would correspond to a t-value, and we don't have to change it to a different unit or anything because it's already in years. And then also we have this right here, which is an interest rate of 2.5%. Of course, we'd have to move the decimal over a couple spots. So if we kind of fixate all of this into the identity of interest equals principal times rate times time, and we plug in all the stuff that we do know into this, what we're going to end up seeing here is that we want to gain $2,000 by starting with an unknown amount of principal and then multiplying that with the interest rate here, which if you move the decimal over a couple of spots for 2.5%, it should come out to be 0.025. And then also multiplying that by the time, which is 5 years, then this should hold. So we want to just be able to solve this for P, right? So ultimately, if you just kind of divide out these couple of numbers, if you divide by 0.025 and by 5, then you're going to be able to solve, right? Another way, I guess, is you could actually multiply and find out what these two numbers multiply out to equal. So if you get 2.5% of 5, it comes out nicely to be 0.125 times P equals $2,000, and then you can divide by 0.125 to get just P alone, and then divide by 0.125 on the other side to figure out what P is going to be. So if we just divide that out, 2,000, and we divide it, we end up getting $16,000 has to be your principal, right? So yeah, you have to start out with $16,000, and then if it grows at 2.5%, for 5 years, it should gain $2,000. So recognize then that would mean you'd have $18,000 in the account, right? Because that's 2,000 more. Awesome. All right, so here in this problem, it's another simple interest problem, but starting at the beginning here, it says that Cody has $825 in a savings account that accrues 0.8% simple interest. When will he have $900 in his account? So we're looking to be able to figure out when, right? So time is kind of an unknown right here. So what we do know is that he has $825 in his savings account, and we want to get to $900 in his account. So if he starts at $825 and he ends at $900, the starting amount we always denote as the principal, okay? But notice that the ending amount, that's actually the amount that's in the account. Going between principal to the amount in the account is the amount of interest, I. So the amount of interest is actually going to be known because it's going to be $75 because that's the amount of increase from $825 to $900. The last thing that we also know numerically here is the annual interest rate. So if we move that decimal over a couple spots, you're going to have a couple of zeros before the 8 right there, and that would be the interest rate expressed as a decimal. So we could actually solve for the time using I equals PRT. It's just that now the t is unknown this time. So if we substitute everything in that we know, we're going to have to put in a 75 for the amount of interest that we want to accumulate. And then the principal, which is the starting amount of 825, would multiply with the interest rate, which would be 0.008, and then with the time. And then we can do some solving and evaluate this here from here. So let me multiply the 825 with the 0.008 and see what that is. Great. So we end up getting 6.6 t equals 75, and then you can divide by 6.6 to solve for the t. I don't think that's going to turn out very pretty. Nope. So when we get that all solved, then t is going to be 11.36. Actually, it just repeats the 3 6's over, so I can put an equal sign instead of a squiggly equals. So 11.36. So remember that t is time and it's always in years, so we can designate then that it would take that many years to be able to get to $900 exactly if you start with 825 and grow at that 0.8% interest rate. All right, one last problem here is that Jorge wants to have $5,000 in 3 years' time to be able to use that money to take a vacation. He invests $4,500 into a simple interest savings account. What interest rate will he need to go on to take the vacation? So we know he wants to have $5,000 in 3 years. So if he wants to have $5,000, that's going to be the amount that he wants in his account, is he wants to have $5,000. And he wants it in 3 years' time. So we know the time is 3. We don't need to change that. He also invests $4,500 into a simple interest savings account. So we know the principal is $4,500. And we want to know what the interest rate is that he will need to go on the vacation. So if you know these three variables, A, T, and P, and you wanted to use, I equals PRT, you'd only be able to plug in a known T value and then a known P value. You don't actually know the I or the R, so you need to know at least one more of them, right? So recognize that there is also the other identity that I equals principal and then 1 plus R times T that we derived earlier, in which then if you did plug in the time and then you plugged in the principal and then you could also plug an amount into this, you could actually use this formula because you have 3 knowns, those ones, and then you could solve for principal or solve for the rate from there. Sorry. We know the principal, the amount, and the time. We can solve for the rate. So I'm going to actually use this identity, and then I'll show you how we could also use this identity in just a little bit here too. So if we plug in the amount that he wants to have of $5,000, and then the principal of $4,500, the number 1 plus R times 3, right? Then we can solve this, and we can actually find R. So what we'd want to undo first of all is we don't want to undo that multiplication by 4,500, which would mean that we would want to divide by 4,500 to both sides. So without doing anything too fancy, I'm just going to leave this side as 5,000 divided by 4,500, and that's going to be equal to now just 1 plus 3r. So what I would then need to do then is I would need to subtract the 1 next. So by subtracting 1, to cancel that out, and subtracting 1, we're going to end up getting then 5,000 over 4,500, and then subtract 1 from it equals 3 times r, right? So you could put that in a calculator and then divide it all by 3, and that should give you exactly what r is. So what I'm going to type in my calculator right now is 5,000 divided by 4,500 minus 1 only. So what I get is 0.1 repeating is equal to 3r. So if then I just divide that by 3, we end up getting then kind of a final answer where r is equal to 0.037, and the 0 and the 37 keep repeating over and over and over and over and over. So 037, 037, 037. So that's actually the interest rate. Now, because that's as a decimal, you'd want to move it over a couple spots to the right now and end up getting 3.703 repeating. That is the annual interest rate at which you would need to grow by. So you can use that formula and that identity, but I do want to show you that we could also figure this out using I equals PRT, because we actually do know the principal rate here is going to be 4,500, and then we do also know the time right here is going to be 3. We don't know the interest rate r, but for I, we know the amount of interest is actually going to be the amount of increase from principal to the amount, which should be $500. So if you set $500 equal to 4,500 times r times 3, then you're just basically solving that 500 is going to equal 13,500 times r, and then you just got to divide by 13,500 to both sides, and what you'll end up getting if you put that in a calculator then is 0.037 repeating, same sort of thing, which then of course solves to the same final answer there.